Good morning, everybody. Thank you for the invitation, Isidore, to this anniversary of your organization, which I see is promoting agroecology in Korea. I'm going to be talking about agroecology and its importance in regenerating, revitalizing peasant agriculture in a planet that is facing many, many crises. We have climate change, biodiversity loss, we have the pandemic, armed conflict, Russia and Ukraine right now, economic crisis and inflation, food crisis. What is important to understand is that all these challenges and problems that humanity is facing are all interconnected. They cannot be addressed in isolation because they are systemic problems and they are interdependent. One of the problems is aggravated. The effects are spread through the system, exacerbating other problems. For example, climate change exacerbates the economic situation. The economic situation exacerbates hunger, and everything is interdependent. Industrial agriculture is one of the key activities that is promoting this cascade of catastrophes that humanity is facing. 80% of the land, of the agricultural land, which is about 1.5 billion hectares, is devoted to homogeneous monocultures that don't have ecological diversity. And this tremendous landscape simplifications across the globe have a huge ecological toll on the planet. We could be feeding ourselves with more than 250,000 species of plants, but there are only 3 crop species, rice, corn, and wheat, which provide more than 50% of the food that we eat. And this is monopolized by high agribusiness interests. And there is data showing that as we simplify our systems, when we have less diversity of crops in the landscapes, you have more possibilities of harvest losses because of disasters, because of climate change, because of pests, because of many other shocks. But when you increase the diversity in the landscape, when you increase your number of crops intermingled in the landscape, you can see that there's a reduction in losses. So the more diversity we have in the landscapes, the more stability we have, the less possibilities we have to lose harvest. One example is in 1970 that because in the United States, because most of the landscapes were dominated by one variety of corn, there was a huge loss of corn production due to a disease. More than 13 million tons were lost in just one growing season. And because these systems then are so vulnerable to pests, diseases, weeds, we have to use more than 5.2 billion pounds of herbicides, insecticides, and fungicides that are injected into the biosphere every year. And these pesticides have huge impacts on the environment, on human health, and the ecosystems. And you can see, for example, that only 1% of the pesticides reach the targets. The rest go into the soil, into the air, into the water systems. In the United States, it is estimated that the costs of pesticide impacts on health and environment is about $10 billion a year. At the global level, we have about 26 million people annually getting poisoned by pesticide use. And the cost of pesticide on agrobiodiversity loss is huge. For example, the loss of biological control of pests because we eliminate natural enemies with pesticides is about $100 billion a year. Soil biota loss, 25 billion, and the loss of yields because of lack of pollinators that are affected by pesticides is about $15 billion. And on top of that, we have pests that are becoming resistant to the different chemicals. For example, there's more than 500 species of insects and mites and other arthropods that are resistant to more than 1,000 different insecticides, which is showing that the chemical strategy is reaching its limits. And when we account for the externalities of all these effects that industrial agriculture has: water contamination, loss of biodiversity, impacts on human health, soil losses due to erosion, the emissions of greenhouse gases. More than 30% of the greenhouse gases that are changing the climate are originating in industrial agriculture. Well, when we put a value on that, which the neoliberal economic model doesn't account for these externalities, it is about 208 pounds per hectare. This is in England. They calculated that if we were able to tax the agribusiness companies or the big farmers because of their environmental impact, they would have to pay 208 pounds per hectare. So industrial agriculture is leading to agro-landscape simplification. For example, here is an example from California, where the small farmers that were growing strawberries, for example, surrounded by landscape, vegetational structures, give slowly the way for monocultures that simplify the landscape in a dramatic way. Well, in Asia, it is known, for example, that rice fields that are surrounded by complex vegetation, as opposed to rice fields that are surrounded by rice fields, and rice fields, huge monocultures. These rice fields that are more heterogeneous have more beneficial insects, more natural enemies that control the pests. Here is an example of, during many, many years, they sampled the amount of predators and parasites that are good insects against bad insects in rice fields surrounded by natural vegetation versus monocultures. And you can see that there is a huge difference in abundance. So what happens is that when you simplify the environment, you are basically reducing the richness and the abundance of the beneficial insects, which leads to more pests and more pesticide use. So it is important to have a landscape matrix that is diverse around the fields as one of the components to reduce pest populations. Well, the other phenomena that is happening is that the traditional systems of production, like coffee, for example, here in Latin America, it is being simplified. You know, coffee by small farmers is usually grown in forests, more than 150 different species of trees growing, and coffee is one more component of the forest. But today, because of market demand, there is a simplification of the coffee systems to systems that have only one species of shade, or to monocultures. So when you go from a system like this, highly diversified, where there are many tree species that are playing many functions. For example, the leaves of these trees fall down and they decompose, providing the fertility for the soil. You don't need chemical fertilizers in this system. Or the diversity here provides abundance of beneficial insects that control the pests against the coffee. When you transform the system into this monoculture, you lose all this, what we call ecological services. All the functions that the trees and the complex systems provide for the farmers are lost. And this system then become highly dependent on external inputs, fertilizers, fungicides, etc. So you can see here in this graph an example of the loss of one of the services, which is the conservation of water. Because in this system, you have less evaporation and less transpiration, less loss of water than in this system. When a drought comes, these systems become very, very susceptible. Why? Because you can see here that in the system without shade, you have very high loss of water, evaporation. Whereas when you have a high shade, the evaporation is much lower. So the system is able to withstand, for example, droughts in a more dramatic way. So climate change.
Professor Altieri,
yeah.
I ask one thing? It's a very interesting example for the coffee farms. Then looking at the latter case, the first case was it has forests. It is a very original coffee farm, maybe. But the next one, is a developed farm, maybe.
Yes, developed farm.
The developer may thought that it is good for the productivity and so on.
Yes.
Then my question is, what about the organic farms, organic coffee?
Yeah, well, there are organic coffee that are like this, monocultures.
Mhm.
There are organic, because you see, organic doesn't mean that it's agroecological. That's very important because there are many organic farmers that do monocultures with what we call input substitution. So instead of using chemicals here, fungicides, chemical fertilizer, they will use organic fertilizers, organic fungicides, but the dependence of an organic system like this will be the same as a conventional farm, as a chemical farm, as a developed farm.
Okay.
So but you can also have farmers that are organic that follow this path also, and these farmers that are organic using shade are also farmers that are more close to the agroecology than these organic farmers here.
Okay. Okay. Thank you.
All right. So we are facing perhaps one of the biggest challenges that humanity has ever encountered, which is climate change. Our parts per million of CO2 is about more than 400 already in the atmosphere, which is leading to major changes. For example, temperature changes. We see a lot of events of rains and hurricanes. There's ocean warming, sea level rising. There's many processes that are happening, and this is affecting industrial agriculture, because industrial agriculture is monocultures that have no resilience against these changes. So it is expected that there could be, by the year 2050, a decline in food production of about 16%, and this would lead to high food prices, elevating more than 150%. So, for example, you can see this plantation. This was a commercial plantation in Puerto Rico for export of bananas, and it was totally decimated by the hurricane, the Hurricane Maria that happened in 2017. In California, now we have excess rain, but in the last 10 years, we had a huge drought, and also in the Midwest of the United States in March 2022, they experienced the highest drought in 50 years, with losses of corn production in about 35%, especially transgenic corn. And here in California, as I was saying, last year we had the driest months on record, dating back more than 100 years, and there has been dwindling water supply, which has forced farmers to abandon more than 531,000 acres of land. But it's interesting to see that small farmers in many countries, I don't know in Korea, but many small farmers cope with climate change, or they are more prepared to face, to minimize crop failure through many practices that they use. For example, in Central America, many years ago, there was a hurricane in the early 90s called Mitch, and researchers found that monoculture small farmers that had monocultures suffer more damage, especially mudslides, in the farms that were monoculture versus the farms that were diversified with agroforestry systems, with soil conservation practices, and so on. In Cuba, they found the same thing. When Ike came, the monoculture system suffered tremendous losses, whereas the small farms that were surrounded by hedgerows or windbreaks, or they had agroforestry systems, they suffered less damage and they recovered faster from the hurricane damage. And in areas where there is drought, small farmers throughout the Americas have many practices that are interesting to increase the resistance to water stress. For example, the Hopi Indians in Southwest United States plant corn, and then they actually change the capillarity of the soil by doing a particular tillage, which doesn't allow for the water to evaporate from the soil. There's in Africa, for example, the system called the Zai, which is a system where it's like a half moon that they do these holes in the soil, and they fill them with the compost from the termite mounds, and then they grow the corn there because it concentrates the humidity, despite the fact that there's very little rainfall. Or farmers, for example, in Mexico, instead of growing corn with beans, which is the typical system, corn is very susceptible to drought, so they change for opuntia, which is this cactus that they use the leaves and the fruits for many uses in Mexico. Or when they plant fruit trees, they use the leaves of the opuntia as a source of water during the establishment of the trees when there's no irrigation available. So it is important to understand that industrial agriculture is not feeding the world. As I said, occupies 70 to 80% of the land, but only produces 30% of the food. But in order to produce the 30% of that food in all that land, it uses a lot of pesticides. It uses 70% of the water, 80% of the fossil fuel energy, and produces 30% of the greenhouse gases. So what we need is a transformation of agricultural systems, what we call a conversion to agroecology, by going from the systems that are pesticide, fertilizer, fuel dependent with very little diversity to systems that are much more biodiverse, more resilient, but that are more intensive in knowledge. See, these systems are very intensive in inputs. These systems are more intensive in knowledge in order to promote ecological processes in the agricultural systems. So what we want to do is move from an agriculture that is input dependent into an agriculture that is process dependent, that is dependent on ecological processes. So what we're looking for is an agriculture that does not depend on petroleum, that are agricultural systems that don't impact the environment and nature, that are resilient to climate change, that are multifunctional, that not only produce food, but they also maintain biodiversity, maintain seeds, maintain the culture of the people in the landscapes, and provide many other services for humanity. And they provide the foundation for local food systems, because one of the messages from the pandemic was that we need to put our food production in the hands of small farmers that are based in local situations, in local areas, more than in the industrial food chain. So what we're looking for is agricultural systems of high diversity, productivity, and high efficiency. And this high efficiency results from having systems where you have integration of crops, trees, animals, with high recycling rates and very low dependence on external inputs, because the inputs are produced on the farm. And this is where agroecology comes in as a science. Agroecology is a science that results from the marriage between traditional knowledge and modern Western science. So what agroecology provides is a kind of a bridge where we promote a dialogue of wisdoms, where the knowledge of farmers is as important as the knowledge that we can derive from Western scientific disciplines like soil science, entomology, biological control, ecology, et cetera, and including the social sciences. So from this dialogue of wisdoms emerge principles, and these principles take different technological forms depending on the local circumstances. So agroecology doesn't work with recipes, like you have to use this compost or you have to use this input. No, it works with principles that then take the form of technologies. So we have the principles and then the practices. So the practices reflect the principles. For example, I don't know if you know that, if you guys know the concept of green manure. Green manure is, for example, producing a legume then you incorporate in the soil for the next crop, like in a crop rotation. Well, that's a practice that is reflecting one of the principles of agroecology, which is recycling of biomass and nutrients. So when the principle is recycling of organic matter and nutrients, the practice is green manuring. And then green manuring sets in motion processes such as nutrient cycling, organic matter accumulation and decomposition, so that the system works well. So in order for an agricultural system to be working healthy and be productive, you have to have these processes: water conservation, biological activity to control pests, nutrient cycling, organic matter decomposition, which also depends on biological activity in the soil. It's like we as humans, if we want to have good health, we have to follow certain principles. And the practice is, don't eat meat, don't drink alcohol, do a lot of exercise, and then your nutrition, your metabolism, your circulation will be well. The same thing with an agricultural system. So where do these concepts come from? The principles of agroecology is not something that scientists invented. I had the opportunity to visit Southeast Asia. I've been in China, I've been in Japan, and I've been very interested in learning how, for example, these traditional rice fields in some parts of China, for example, have worked for centuries. They have stood the test of time. And they are the same system that existed, thousand years ago. Well, here farmers, as you know, because you grow rice in your country, they grow crops in the rice in terraces, obviously, surrounded by a natural matrix of a lot of different fruit trees. And then they have different varieties of rice mixed together, and they do rotation. When there's the dry season, they grow legumes and other crops. But in China, for example, the presence of fish, carp, is very important because it's not only a source of protein, but they also actually play a very important function in controlling weeds, for example. The fish will eat the weeds, or they will eat the pests. So they eat the weeds, and then they have this behavior of pushing the rice, and then the leaf hoppers fall and they eat it. So they're playing a function of biological control. Then they allow the growth of azolla, which is this mixture of fern and an algae that fixes nitrogen. About 40% of the nitrogen, which is 200 kilos per hectare, is used by the rice instead of a chemical fertilizer. And then before this azolla suffocates the oxygen of the water system, which would actually kill the fish, then they bring the ducks, and the ducks eat the azolla. They also control pests. They produce a manure, feces, that will help in the fertilization. So basically, you can see that the farmer, the traditional farmer, the rice farmer, all he or she does is to assemble a certain biodiversity in the system. Different components that are going to be interacting one with the other. The rice with the azolla, the weeds, the ducks, the fish, they're all interacting. And through these interactions, they're promoting the processes of biological pest control, of nutrient cycling, et cetera, et cetera. So this is what inspired agroecologists. For many, many years, we have studied these traditional systems, and we have seen that there are mechanisms at work that we need to rescue, to transform into principles to guide the transformation of modern agriculture.
Yeah, it's a very exciting model for the rice field. Then I would like to ask about the fish. Are the fish used for the marketing? I mean, is that a product from the paddy?
Yes, the fish is used for local consumption and also for marketing. And sometimes they dry them. Sometimes they sell them for, fresh fish, or they sell dried fish in the local markets and in the regional markets.
Very good.
So,
and
So it's a source of protein for the local community, it's a source of income, but also plays the ecological function in the rice system.
Yeah. Then is this model common in the region? Or if it is only one farmer's experiment, then
no.
Yeah.
It's very common in many parts of China, but it is disappearing slowly. So
Yeah.
there is a program of FAO, the Food and Agriculture Organization, called GIAS, Globally Important Agricultural Heritage Systems, where they are trying to preserve the systems around the world, different types of agricultural heritage systems, because they are disappearing and they are a very important source of knowledge and agrobiodiversity for the world.
Okay.
So, but not only in Asia, we're going to find these systems, we can find them also in Latin America. For example, the milpa is the traditional system that is in Mesoamerica. It's a system that has been there for hundreds of years, thousands of years. And you can see that is a combination of corn, beans, and squash, okay? And each one of these crops play a function in the system. So you have many interactions happening below ground and above ground. So if you look at below ground, for example, the beans provide nitrogen to the corn because they fix nitrogen, and the corn serves as shade and also as a support for the beans to climb. And the squash covers the soil, protecting the soil against erosion and against weed competition. So when I was a young student, I studied these systems, and I found that when you intercropped the more than one crop together, you would have a very complex insect community. You would have herbivores, some of them would be pests, but you would have also a huge array of natural enemies, beneficial insects, predators, parasites that would be controlling this pest. Okay, so for example, we found that in the monoculture, you have more pests than in the polycultures, okay? And this is due to the fact that in the polycultures, you have more environmental opportunities for beneficial insects to be there to control the pest than in the monoculture. The same thing happens with weeds. For example, here you can see a corn-bean association, and you can see that there's no weeds here because the beans are using the niche that otherwise weeds would use. So if you take the beans out, then you have a very complex weed community colonizing the corn because you left the niche open that before the beans were utilizing. So experiments that have been done in many parts of the world, but this particular one in India shows that, for example, the wheat biomass, this is the weight of weeds in a monoculture, is very high when you have a monoculture of sorghum. But when you intercrop the sorghum with cowpea, you can see that you reduce the wheat population dramatically, and you improve the yield of the sorghum. So when we look at these systems that farmers use, very complex intercropping systems, you will find that there are many processes that happen below ground in the soil. For example, facilitation, resource sharing, complementarity between the crops. And one example would be, for example, when you combine corn and fava bean. Fava bean is like a legume, it's like a bean. And then what happens is that this plant fixes nitrogen and helps the corn, but also produces some acids, organic acids, that actually promotes the acidification of the rhizosphere, mobilizing phosphorus that the maize absorbs. So this plant is helping to mobilize phosphorus in the soil that the plant will use, but the mobilization of the phosphorus is because of these acids that are produced by the roots of the fava beans. So when you compare the productivity of corn, bean, monoculture versus polyculture, you have to use a particular formula, because here, for example, if you look at corn production in monoculture is 4 tons 4,000 kilos, versus the intercrop 3,000 kilos. And the beans would be 1,000 monoculture, 750 in polyculture. So you would conclude, oh no, the monoculture is more productive than the intercropping, because the corn produces more than the monoculture, than the intercropping, and the beans in monoculture produce more than the intercropping. But what happens is you're overlapping two systems. You're putting corn and beans in the same field at the same time. So for that, you have to use a formula called the land equivalent ratio, which is this formula where you have the corn yield in polyculture over the corn yield in monoculture, plus the yield of the bean in intercropping over the yield of the bean in monoculture. And when you get a value higher than 1, it means that your polyculture is more productive. It's over yielding, they call it. So 1.5 means that you need 1.5 hectare of monoculture to obtain the same production in 1 hectare of polyculture, because the polyculture uses the resources like water and nutrients and sun energy much more efficiently. And the other thing is that different cases of intercropping, you can see that the yield stability of the intercropping of the polyculture is better than the monocultures. That means, for example, if you have cassava with beans and you have a climatic event, you lose 33% of your production. Whereas in the case of the polyculture, you lose only 27%. Or cassava and sweet potato, 24% versus 13%. So there's less yield instability in a system of polyculture than monoculture. And then the other thing that is important is that farmers, this is in Mexico, but happens in many parts of the world, that many times we just focus on the field, what is the farmer producing inside the field, and we ignore the surrounding vegetation. And it turns out that when you look at that, in the case of the study in Mexico many years ago, you find that, for example, here you have 11 crops, and you have also weeds that the people eat. They eat amaranthus and portulaca oleracea and many plants that we call weeds, but farmers call quelites in Mexico. So they produce a lot of food, but the border, which we did not account for, these borders also produce fruit trees and vegetables and herbs. And when you look at the total income of the farmer, 1/3 of the income comes from the borders, not from the field. And usually these borders are much more stable when there's a drought or some kind of a climatic event than the crop field. So it is very important to understand, to look at the total production of a small farmer as opposed to the production of just the crops in the field. So this leads me then to the concept of total production, because many people argue that large-scale farms are more productive than small-scale farms. So, but it turns out that, for example, you could have a large farmer that has, 108 hectares of corn and produces 10 tons of corn per hectare. And then you have a small farmer that has 1 hectare, but produces 1 ton of corn per hectare. But in addition to corn, it produces beans, fruits, eggs, milk, etc. Well, that's total production. When you look at the total production of the farm, this farm is 10, 20 times more productive than the large farm. So this is exemplified by the coffee systems that I was showing before. This is in Mexico. This is a forest. Inside the forest, you have the corn, the coffee. Inside the coffee system, you're gonna find many species of trees, many species of plants that are useful. So the farmer, this is the coffee plant, and here you can see all this complex vegetation. This farmer has to have knowledge about how to manage this complexity. When you go and you prune, when do you harvest, when do you do different practices to manage this complex system, not just the coffee, the whole system. And from this system, then you get coffee, but then you get a tremendous amount of other products, flowers, palm trees, you get cane, you get medicinal plants, you get fodder, you get many food crops, etc., etc. So this is the concept of total production. And many of these products are for the food self-sufficiency of the community, but also many of them are sold in international markets, in national markets. For example, coffee, macadamia, flowers are all sold in other markets. These farmers manage the soil in a way that increases their organic matter, increases their stability and the structure of the soil, their aggregation, we call. And when you have a soil rich in organic matter, you can actually increase, for every 1% increase in organic matter, you can actually store 20,000 gallons of water per acre, because the organic matter acts as a colloid that absorbs the water. This is very important for times of drought, to have this rich organic matter soils. And this organic matter is the basis that provides the energy for a whole food chain of microorganisms that are in the soil. Some of them are pathogenic, but many of them are beneficial microorganisms that are playing many functions in the soil. Some of them decomposing organic matter. Some of them are antagonists against the diseases. They kill the diseases. Well, one component here that is very important in the food chain in the soil are what we call the mycorrhizae. Mycorrhizae are these fungi that play many functions. They can increase the resistance against diseases. They promote plant growth. They also solubilize phosphorus and nitrogen for the crops. And here you can see a tomato plant of the same age, the same variety, but this one has mycorrhiza, the fungi associated with it, and this one doesn't. So you can see that the growth of the plant and the way the root system works is much more developed than this variety without the mycorrhiza. So what happens is that this is a root, and this is what we call the root hair. The root hair is about 2 millimeters of length, but you can see that the mycorrhiza, the fungi, the hyphae of the mycorrhiza, extends, biologically speaking, the root system 40 times, which allows the plant to absorb more nutrients, more water, and at the same time, all this fungi here protects the roots against pathogens, against bad diseases that are going to come and try to kill the crop. So, to start summarizing, it turns out that 50 to 70% of the food that we eat comes from small farmers, from peasants in the world, depend on the country, okay? But they only control 20 to 30% of the land. They use very little water. They use very little energy, pesticides, and so on. And so the question is, if we really want to feed the world, why don't we give more land to the small farmers? Because this is very important. Because if really the purpose of feeding the world if that's the purpose, then we need to support the small farmers, because large-scale agriculture, as we have seen, doesn't feed the world. So there are many examples of small farms that have been following agroecological principles that allows the production of food without external inputs, showing the potential productivity and resilience of these farms. This is an example from Chile, South America, where I was born many years ago, of a half-hectare, 1 acre farm divided in various plots with a backyard, with raised beds, and with a cow, with chicken, with bees, etc. Basically, after 3 years of conversion to agroecology, also I need to show here that this farm, this piece of land, was surrounded by fruit trees also. We found that actually there was so much production of food after 3 years without any inputs from the outside, that the family didn't need to buy any food except oil and salt and rice, because they don't produce rice in this area. So all the food, 90% of the food that the family of 5 produced in one acre of land was able to feed the family. But on top of that, there was a surplus, because the people, a family of 5 is not going to eat 2,500 eggs, in a year, and it's not going to eat 3.16 tons of 3,000 kilos of vegetables. So there was a surplus that when it was sold, actually, it was about $2,500 that the family got. So this example shows that in a small piece of land designed agroecologically, you can produce food to feed your family. So you're saving $200, $300, $400 a month in food. Second, your cost of production went down to almost zero, so you don't have to spend money in inputs. And then on top of that, you can sell the excess food in the market, okay? So that's what leads to what we call the 3 sovereignties: technological sovereignty, food sovereignty, and energy sovereignty. This is another example from Cuba. This family is an active family in promoting agroecology. They obtained land many years ago. At the beginning, it was a monoculture of tobacco and corn. But then when they were trained in agroecology and they adopted the agroecological design, then they transformed their land into a very complex farm divided with networks of hedgerows and that play many important functions. One of them protect them against hurricanes, but also they produce food here, they produce fodder, they produce wood, etc. And inside the farm, you have intercropping systems, agroforestry systems, silvopastoral systems, crop rotations, all kinds of different things. And what they found after research that was done by their daughter that did a PhD in agroecology, they found that actually the dependence of energy went down to almost zero. From from 1995 to 2015, they were able to almost went to zero dependence on external inputs from the outside. And they were able to produce enough protein per hectare to feed 34 people. They had 10 hectares, so they could feed 340 people with protein and with an energy efficiency of 30. That means they put 1 kilocalorie and they obtain 30 back. That's a very efficient agriculture. Industrial agriculture has an energy efficiency of 1.5. So this model is 20 times more efficient energy-wise than the modern agricultural systems. But then we cannot just talk about agroecology to design just the farms. We need to understand that farms are located in landscapes, in watersheds, and that if those watersheds are degraded, then your production in your farm, although it is designed agroecologically, is not going to be optimal. So you need to work with restoration of the landscape that surrounds your farm. So there are many, many elements that we can use. I'm sorry, this is in Spanish, but basically there are many, many techniques, models, designs, like, for example, hedgerows, windbreaks, et cetera, that are providing tools to restore the landscapes that surround your farm. So here we see an example of farmers in Mexico, in Oaxaca, that had very degraded environments, but they decided to start restoring some of their production systems. They started with the reforestation of the top of the mountain. Then they started, with soil conservation practices and water harvesting. It's very important because it turns out that in this area, it rains very little, maybe 300 millimeters per year, but then they can store that water for the dry season. And then have enough water to grow their crops in small plots. Depending on the amount of water they have, they will have the size of the plots. And you can see here they're irrigating amaranthus, which is a very important crop, very high in protein in these communities. This is another example from from Colombia, where farmers have started to restore the watershed in order to have enough water, but then they changed the monocultures into systems that they started introducing, for example, Tithonia diversifolia, which is a composite plant that it allows for the growth. It's very similar to the sunflower that allows the production of a lot of biomass. They started growing coffee and avocado and citrus trees with partial shade of Ricinus communis, castor bean. And then little by little, the system started evolving and evolving into a coffee system with shade of different fruit trees. And when you look at the system from above, you can see that it's a highly diversified farm with corridors of Tithonia, which provides green manure. It provides flowers for pollinators and fodder for animals, plus all these species that are interacting, bananas and coffee and avocados and citrus trees and so on. So I think that what agroecology is potential is, and is happening given the crisis, the poly crisis, is that it's leading to a process of repeasantization. By revitalizing small farmers, agroecology moves peasants to autonomy from inputs and markets and out of debt. And by recovering and restoring the territories away from agribusiness via land reform, occupations, and other mechanisms, you can see that the repeasantization process is happening. Why is so? Via Campesina and many other movements, peasant movements, have adopted agroecology. And why is that? It's because agroecology is socially activating. It requires the participation of the community. It is based on it uses local resources, so it's economically viable, doesn't depend on external inputs. It's culturally appropriate because respects and mobilizes the traditional knowledge. You see, the Green Revolution changed. It didn't change one seed for another. It changed the knowledge from another. So agroecology doesn't change the knowledge. It builds upon the knowledge of the farmers. It's ecologically sound because revitalizes, optimizes the systems. It doesn't change them dramatically, and provides the principles to reach food sovereignty. So La Via Campesina, as you know, is a big movement in the world, and I know that in Korea you have main actors in this movement, and it has some principles of distributive justice, ecological sustainability, and procedural justice. That means that, basically, we're talking about land reform, we're talking about the state supporting the small farmers, agroecology as a main technical strategy, and the social movements. And in their declaration of Mali in 2015, actually, the Via Campesina adopted agroecology as the main strategy to reach food sovereignty. So we need to transform the food system, not just the production systems. And this will require a major shift from societies embedded in the market economy to a greater reliance on alternative food networks, reducing the distance between producers and consumers, and ensuring that everybody has access to healthy food and accessible food. And this is what is happening right now. We have these corporations, which Van der Ploeg, which is a rural sociologist from Netherlands, talks about the corporations that have strangled the food system. They control what farmers are going to produce, what technology they're going to use, and through the supermarkets, they determine what people are going to eat, the quality of the food, the price of the food. So they have controlled the food system. And what he proposes is a bypass in which you have farmers, small farmers organized, controlling their territories, and creating local markets and other initiatives in which there is direct contact between consumers and producers. So there are many, many examples of this. For example, Ecovida in Brazil, it's a network of farmers and consumers where you have 180 municipalities and approximately 2,400 families of farmers and around 12,000 consumers that are already in networks of local markets that are allowing for this direct contact between consumers and producers, in which there is exchange of money, but it's more ruled by solidarity economics, circular economy, rather than the market economy, the neoliberal market economy. So here you can see examples of different associations where farmers, bring their food to the people at very reasonable prices. It's not more expensive than conventional. Okay, it's the same price. So there are many benefits of supporting small farmers, because it enhances the food sovereignty, promotes local economic growth, generates employment, reduces poverty, promotes diverse diets and better nutrition for the community. And one thing that is very important is that we cannot put the weight of the change of the food system on the farmers only. We need, as consumers, which we all are, we all eat 3 times a day, we need to understand that eating is both an ecological and political act, and that we as consumers, if we support the small farmers, we're going to help to create socio-ecological sustainability and resilience in our communities. So we have a political role. We need to be more educated about the multiple ecological, social, cultural, and economic roles of peasant agriculture. We need to actively participate in creating and strengthening the bypass that I was talking about, the local food systems. And we need to pressure the local, national, regional politicians to adopt agroecology. And we need to scale up agroecology through farmer-to-farmer networks, funding research and education in the universities, providing and enabling a public policy environment that is going to be conducive. It's taking special actions to empower women and young people, and making strategic alliances between consumers and social movements. And there have been some studies showing that where agroecology has expanded rapidly, like in Cuba and other places, Brazil, there has been some common factors. For example, the existence of a crisis, that's a mobilizing driver. And what more crisis than what we have today? We have so many crises that we should be moving quickly to agroecology. There has to be social organization. That is key. Farmers have to be socially organized. There has to be networks between farmers to share knowledge and experiences. There have to be agroecological practices that are very effective. We cannot lose our time trying things that don't work. There's already well-established principles of agroecology and practices that are effective. We have to have favorable markets and also favorable policies. And there are many countries in Latin America that have initiatives that promote agroecology. Right now, Brazil, for example, well, in 2013, they created the national law of agroecology, but then when Bolsonaro, the last president, was in power, he didn't implement the law. But now that Lula's back, then maybe things are going to change. But now Chile, for example, with the new government of Boric, and here in Colombia with Petro, we are seeing that the government is becoming interested in promoting agroecology. And one example of the successful programs of Brazil was the public procurement of food. That means that, for example, the school lunch program. That means that the government buys from small farmers 30% of all the production to feed the children in the schools. So 2,000 municipalities were participating with 40 million students per day being fed with food from the small farmers that was produced agroecologically. So with that, I would like to finish by saying that I know that the ecological, social, economic, and political context between Latin America and Korea are different, but I think the struggles of the farmers and consumers are the same, especially in these times of polycrisis, where we have inflation, where the food is becoming more and more expensive, where we have climate change. And I think that the principles of agroecology are universal And many of the experiences in Latin America can be extended to Korea and vice versa. If we knew more about what the Korean farmers are doing, we could also learn from them. Thank you very much.